Hello everyone and welcoming back to my channel. In the today's session we are going to talk about LVDT. In this session we are going to talk about LVDT construction, working and talk about LVDT in detail. If you want to learn something from my video, so watch my video till the end. So let's start the video. First of all, we will talk about the full form of LVDT. So LVDT full form is linear variable differential transformer. As the name suggests, many people get confused that is the transformer, but actually it is not a transformer, it is a transducer because its working principle is same as the transformer, that is mutual induction principle, and also the output across secondary coil is in the form of differential voltage. That's why it is a name linear variable differential transformer. Friends, it is categorized as an inductive transducer used to measure that the speed or position of an object. Generally, most of the inductive sensors work on the principle of transformer. Now, let's discuss the complete concept of LVDT in details. So, first of all, what is LVDT? LVDT is a linear variable differential transformer. Is an electromechanical type inductive transducer that converts uh, rectilinear displacement into the electrical signal. Since LVDT is a secondary transducer, hence physical quantities such as force, weight, tension, pressure, etc. are first converted into displacement by a primary transducer. Then LVDT is used to measure it is in terms of corresponding electrical signal. As LVDT is an AC control device, so there is no electronic component inside it. It is the most widely used in inductive sensor due to its high accuracy level. Its electrical output is obtained because of the difference of secondary voltage, hence it is called differential transformer. Now we will talk about the LVDT's construction. LVDT consists of one primary winding P and two secondary winding S1 and S2 mounted on a cylindrical former. Both the secondary winding S1 and S2 has an equal number of turns and is placed identically on either side on the primary winding in such a way that the net output will be the difference of the voltage of both secondary winding. There is a movable soft iron core placed inside the former. As shown in the figure, hydrogen annealing is done on the form of core of reduce the harmonic residual voltage from the core and thus provide high sensitivity. The movable core also be laminated in order to reduce the eddy current losses. The displacement to be measured in attached to this movable soft iron core. LVDT is placed inside this stainless steel housing because it is provide electrostatics and electromagnetic shielding. Now friend, we will talk about the working principle of LVDT. The working principle of LVDT is based on the mutual induction principle. When the AC excitation of 5 to 15 volt at the frequency of 15 to 400 Hz is applied to the primary winding, then a magnetic field is produced. This magnetic field induces a mutual current in secondary winding. Due to this, the induced voltage is secondary winding S1 and S2 are E1 and E2 respectively. Since both the secondary winding are connected in the series opposition, so the net output voltage will be difference between both induced voltage, that is E1 and E2 in the secondary winding. Hence differential output LVDT will be E0 is equal to E1 minus E2. Now friend, according to the position of the core, there are three cases that arise. So let's discuss these three cases one by one in detail. Case first, when the core moves toward S1. When the core of the LVDT move toward secondary winding, that is S1, then in case the flux linkage with the S1 will be more as compared to S2. This means the EMF induced in S1 will be the more than induced EMF S2. Hence E1 greater than E2 and net differential output voltage E0 is equals to E1 minus E2 will be positive. This means the output voltage E0 will be in the phase with the primary voltage. Then case 2, when the core is in null position. When the core is at null position, then the flux leakage with both the secondary winding will be the same. So the induced EMF, that is E1 and E2 in the both winding will be the same. Hence the net differential output voltage E0 is equal to E1 minus E2 will be 0. That means E0 is equal to E1 minus E2 is equal to 0. It shows no displacement at the core. Then move on last case 3. When the core moves toward S2, When the core of LVDT moves towards secondary winding S2, then this case the flux linkage with S2 will be more as compared to S1. This means the EMF induced S2 will be more than the induced EMF S1. Hence E2 greater than E1 and the net differential output voltage E0 is equal to E1 minus E2 will be negative. This means the output voltage E0 will be in phase opposition 180 degree out of the phase with the primary voltage. So friend, these are the LVDT construction and working. I hope you like my today's video. If you like my video, then please like and subscribe. And friend, don't forget to press the bell icon. See you in the next video. Till then, goodbye. Take care.